Hey, welcome everyone. This is Mr. Spiels. I'm going to be helping you out with some basic derivative rules here to get us started. And to kind of give you a little background here, so we've already learned how to find or take derivatives using the limits process, right? We've done this last couple days. For example, we're trying to find the derivative of something. We take the limit as x approaches h of x f of x plus h minus f of x over h, right? That's what we've done the last few days, and that's great. But if you have a longer function, that can get pretty tedious. So the point of this is to kind of go through some shortcuts or some basic rules that can apply that will be much quicker and easier and cleaner than using the limits process here that we've used in the past for finding derivatives. So let's start with the basics. Derivatives of basic polynomials. Let's start with something called the constant rule. Okay, so this is basically how you read this is the derivative with respect to x of any constant we're going to call k is always going to be 0. Okay, so for example, the derivative of 5 is going to be 0. The derivative of 3 is going to be 0. Any constant, the derivative is always equal to 0. Okay, rule number 2, the power rule. Okay, the way to read this is derivative with respect to x of x raised to any exponent n is equal to, well, it looks like we just take the exponent out front, okay, n times x raised to the n minus 1. Okay, so you're subtracting a number from the exponent. You're taking the original exponent, placing out front, and subtracting from that exponent. This will make more sense once we do a couple examples together. Okay, so that's basic power rule. The third rule is called the constant multiple rule. Okay, so again, derivative with respect to x of any constant times a function or a variable. Okay, we keep the constant and we take the derivative of what's next to it. So that's constant multiple rule. Consider c to be your constant. Okay, that's what this means. Okay, and then finally the sum and difference rules at the bottom here. Derivative with respect to x, if you're adding, subtracting terms together, functions together, you're just taking the derivatives of each one individually and adding and subtracting them together. Okay, so here you take the derivative of f of x plus, then you take the derivative of g of x. If there was another one after it, you'd keep going. Anyway, that's what these little tick marks here mean. That means prime, or that means you've taken the derivative of it. Okay, so f prime, g prime. Okay, so let's start doing some examples together using these 4 rules that we just talked about. Okay, so I'm going to start with example 1. Okay, so it says find the derivatives of each of the following functions. Example 1 is the original function is f of x equals 7. So how do we take the derivative of that? Well, let's look back at our rules. 7, there's no exponents, there's no constant or anything in front of it, or variable to go along with it, I should say. It looks like it's just a constant. It's just k. All right, so we always said the derivative of a constant is always going to be equal to 0. Okay. All right, and to be honest, that, like, if you wanted to picture it, that would make sense, right? Think of it as you have a graph. All right, f of x is equal to 7. Well, let's say 7 is up here. And y equals 7, or f of x equals 7 would look something like this. Well, remember, the derivative is the slope of a line tangent to the graph. So if this is a 0 slope, the line tangent to that would also have a 0 slope, so that would make sense. Okay, so that's the derivative. Next one, example 2, is let's try x to the third. We want to find the derivative of x to the third. Okay, so let's look back at our rules. This one looks like we could use the power rule, right? X raised to the something, x raised to the n. So in this case, it's x raised to the third. Well, our power rule tells us that we can take that exponent, place it out front, keep my x, and subtract 1 from the exponent. Okay, so let's do that. So the derivative, actually I'm going to start writing it this way, f prime of x, that means the derivative, is equal to, I'm going to take the 3 out front like the rule tells me to, 3x, and then I subtract 1 from the exponent, so 3x to the second. Okay, and if you went through the limits process, f of x plus h minus f of x all over h, and you expanded that and canceled out and worked that all the way through, this would be your answer. Okay, it's just a shortcut, really quick way of doing it. Okay, example 3 is negative 3/2 x, or negative 3x over 2. Okay, again, let's look back at those rules. Well, it's not just a constant, right, because we have a variable next to it, so we're not going to use that one. Power rule, well, let's see. Exponents, well, I mean, technically I have a 1 here, but let's see what else we can use. Constant multiple rule, so a lot of times this one can be used in situations like this where you have, you can really split this up. This negative 3 over 2 can be considered your constant, right? And then you have the x next to it on top. So this is no different. I mean, if you wanted to make more sense of it, this is no different than writing negative 3 over 2x, right? So using our constant rule, we keep our constant and we take the derivative of the variable next to it, okay? So I'm going to say f prime of x is equal to, well, I'm going to keep my constant, negative 3 over 2. Okay, so let's take the derivative of x to the first. Well, if I did that, I'd be bringing this 1 right here. Okay, 1 times negative 3 over 2 is still negative 3 over 2. But then it would be x to the 0, right? Okay, well, let's think about that. X to the 0, if you think about your exponent rules, anything raised to the 0 is always 1. Okay, so I can reduce this, or simplify this, I should say, as negative 3 over 2 times 1 is just negative 3 over 2. Okay, again, use the constant multiple rule. Here's my constant, okay, kept my c, and I took the derivative of x. Okay, when I take the derivative of x, it just becomes 1, so it's negative 3 over 2. Okay, let's try another one similar to that. Again, if it helps, you could rewrite it so it looks like this. In that case, again, let's look at this. We might use a couple rules here. You got your constant rule, right? We also have an exponent of 2. Okay, so that still comes into play. So let's talk about that. F prime of x be equal to, well, again, 4/5 is my constant, right? We said we could view that as our constant. And take the derivative of what's next to it. So if I'm taking the derivative of what's next to it, remember this would have to be the power rule, right? Okay, so let's take that 2 out front. So now that's going to be, so I'm going to go like this. Let's say times 2 x to the first. And I'm actually going to put this over 1 if that makes sense. Okay, so that would be 8 over 5x. Okay, so again, here I started with my 4/5, x to the second. I kept my 4/5 as my constant, but I still have to take the derivative of what's next to it. So I pulled the 2 out front. 4/5 times 2 is 8/5. X to the, and I had to subtract 1. Okay, so just x. X to the first is just x. Okay. All right, let's try 2 more examples. Okay, example 5, we've got x to the third minus 4x plus 5, and we want to find the derivative. So f prime of x. Well, again, let's look back here. It looks like we're stringing together a bunch of terms here, adding, subtracting, so we could use our sum and difference rules. Basically, all it's telling us to do is take the derivative of each one separately and add or subtract them together. Okay? So let's take a look at that. Let's start with this first one, x to the third. Well, how can I take the derivative of that? And that would just be a power rule, right? Something raised to a power. So, again, I know I keep flipping back and forth here, but the power rule is we pull our exponent out front, subtract 1. So this would be 3x, okay, to the second. So pulled my exponent out front, subtracted 1. Now I'm going to go minus, and now I can take the derivative of this one separately, the second term. Okay, this looks like a constant multiple rule because it's just 4x. Okay, so again, keep my constant. The derivative of the x is just x to the 0, which is just 1. So 4 times 1 is just 4. Okay, plus, now I take the derivative of my last term. Okay, 5 is just a constant. Again, constant rule, constants are always going to be 0, so plus 0. And just to simplify this, it'll be 3x squared minus 4, and there's your answer. Okay. Again, I know I kind of skipped a step with the x to the 0 right here, but really, when you have an x and a coefficient next to it and you take the derivative, it's just the coefficient, right? Because if this were to become x to the 0, it's just times 1. So really you just drop this x and you just leave the 4. Okay, that's really the way it works for any time you have an x with a coefficient next to it. A little bit different when you have a power up here, but when it's just an x, you really just drop the x and leave the number. Okay, last one. So we're going to say this is g of x. So now this is g prime of x. Again, we are adding and subtracting terms together here, so we're just going to take the derivative of one at a time. So here, looks like I can use a power rule here. If it helps to rewrite this, let's do that. This is the same thing as negative 1/2 x to the 4th. Okay, I just turn this into this. It's the same thing. Plus 3x to the 3rd minus 2x. Okay? All right, so how does that help us? Well, on this first one, we can use the power rule by taking our power, our exponent, bringing it out front. Okay, so that's going to be, I'll simplify this later, but I just want to show you guys. Negative 4 over 2 x to the 3rd. Okay, brought my power out front, subtracted 1. Plus, now we go to the next one. Looks like we have another power rule. I can bring the exponent out front here. So that's going to be 9x, and now I subtract 1, squared. Minus, now we go to this last one. Again, this is similar to what we just did up here, where we just have the 4. Same thing. Instead of writing the x to the 0, I'm just going to drop the x, and that's just going to be 2. Okay. I'm going to simplify this one step further. This would be negative 2 x to the 3rd plus 9x squared minus 2. Okay? And if you think about this, this is a lot quicker than if I were to try to do the limits process and plug that in and work this all out. That would take much longer than using these basic rules. So hopefully this helped. Use these to try a set of example problems on your own and check the answers.